Hi everybody, it's Miss Austin. I'm going to be doing the lesson 14 practice problems. Here we go. Number 1, we know these things about a polynomial function, f of x. It has exactly one relative max, it has one relative min, it has exactly 3 zeros, and it has a known factor of x minus 4. Sketch the graph. There is many possibilities for this. They're not giving us everything. They just want to see if you can, with the given information, make a picture. I know if x minus 4 is a factor, then the intercept to that is positive 4. If it has exactly 3 zeros, that means it's a third degree. So it's going to be going up over here and down over here. They didn't tell me that the leading coefficient is positive or negative. So you could do up over this, you could reverse it, right? And it has one relative max and one relative min. Let's just peek down here. That's a relative max. It's called a relative max because it's not the maximum. Look, this problem has no maximum because it keeps going forever and ever and ever. But in this area, that is the highest. And this is called a relative min because this problem, look, it has no minimum. But in this area, that's the minimum. So it's going to have, I guess, maybe a mountain and a valley, if you want to say it that way. And I could make it look just like this. I don't know what the other two roots are. They didn't tell me. So I'm just making them up. And you could do it the other way. I'll maybe show you the other way too. So let's just make up 2 more zeros. Let's just say that it touches at this one and it touches here. And then here we go. I'm going to have one relative max, one relative min, boom. There we go. Does it have 3 zeros? 1, 2, 3. Was one of them that? Yes. Does it have one relative max and one relative min? Yep. Now, I don't know if it actually goes this way. That's only if it has a positive leading coefficient. If it had a negative one, it would look something like this. It would still touch at positive 4. 1, 2, 3, 4. Let's just, I'll use the same ones. What did I do there? 1, 2, I did 4. 1, 2, 3. But maybe it goes like this. So it's the min, then the max, right? That would be okay too. It touches at 4, which is this one. It's got 3 zeros. It's got one relative max and one relative min. This would just be if there was a negative number in front of the whole thing. Okay? Lots of possibilities. Number 2, Maya graphs a polynomial function f of x that has 3 linear factors, x plus 6, x plus 2, and x minus 1. But she makes a mistake. What is her mistake? Well, let's look. She graphed it 6, 2, and negative 1. If the factored form is written like this, okay, we love factored form because we can tell where the intercepts are. But the intercepts are whatever turn these into 0. So imagine you just do them each individually. What would turn that guy into a 0? A negative 6, not 6. So it should be touching at x equals negative 6. What would turn that middle one into a 0? Negative 2, not 2. She forgot to figure out what makes these 0. She just took these numbers. And 1 would turn that into a 0. So she did not find the numbers that make those factors 0. All right, number 3. Here is the graph of a polynomial function with degree 4. Even degrees, right? Both ends going together. Select all statements that are true. The leading coefficient is positive. If it's even, both the ends are going up. Let's just say it's x to the 4th. I don't know. But both the ends are going up if the number in front is positive. That is true. If it was a negative, then both the ends would be going down. The constant is a negative. The constant is your y-intercept. Look right here. That's not in the negatives. It has 2 relative maxes. Your relative maxes are like your mountains, the top of your mountain. I only see 1. No. It has 4 linear factors. The factors are where it touches the x-axis. 1, 2, 3, 4. And how do I know that those are all linear? Because it goes through at those points. They each count once. Yes. One of the factors is x minus 1. If it touches at 1, then that would be true. Does it touch at positive 1? No. One of the zeros, that's another word. You can call them x-intercepts. You can call them horizontal intercepts. You can call them zeros. Is at x equals 2. Now, if they flat out say what it equals, you don't have to switch the sign. It's not written in factored form. Is it touching at 2? Yes, that's one of the zeros. Why is it called a zero? Because it would turn the equation into a zero. And then letter G, there is a relative min between 1 and 3. Here's 3, here's 1. Is there a relative min between those? No, the relative min is right there and right there. No. Number 4, state the degree and end behavior of f of x. Explain or show your reasoning. Well, all you got to do is look at this. It's an odd with a positive. That means it's going to go something like this. But we have to say it in mathematical terms. So as x gets larger in the positive direction, you could use an arrow. F of x, oh, Miss Austin, stone cold busted. Miss Austin, I just realized I didn't scam the thing. 3 is not the highest. It's actually 5. Oh, epic fail. Start over. The leading coefficient, they didn't put it in order for me. They didn't put it in order from greatest power. That's my leading term. It is odd, but it has a negative. So it's going up over here and down over here because of the odd. The negative with an odd. The odd makes it go in opposite directions. The fact that it's negative means it's going up over here and down on the right. All right, redo. As x gets larger in the positive direction, so as I'm going over this way, what's happening to the graph? F of x gets larger in the negative direction. So as I walk to the right, it was going down here. Turn around. As I get bigger in the negative direction with x, as x gets larger in the negative direction, what's happening over here? The graph is getting bigger in the positive. F of x, which just means the outputs, gets larger in the positive direction. All right, Miss Austin did not make up that wordiness, all right? Number 5, is the graph of g of x, is this graph g of x, which is x minus 1 squared times x plus 2, or h of x, x minus 1 times x plus 2 squared? Explain. Let's look. It's touching at negative 2, which means it should be positive 2. That's looking good. And 1, which should be negative 1. But notice these. This is called the multiplicity. If a factor only occurs once, right? How do I know it occurs once? Because there's no power here. I mean, technically there's a 1 there. It means it's going to go straight through like a line at that point, because x to the first is a line. So if I go to negative 2, do you see how it's going straight through? And this one is squared. That means it's going to behave like an x squared, which is a curve at that number. See that? See how it's bouncing off because of the 2. So this one is correct. This one is not, because there's only one of these. That's saying it would look like this. If I went through 1 and negative 2, if there's a x plus 2 squared, that means it would bounce here and then go straight through at the positive 1, reversed. This is actually what's happening. It's bouncing at the 1, which means that counted twice, and it's going straight through with the 2, negative 2, which means it counted once. So this is g of x. You could put something like the x minus 1 squared. That's how come you knew. All right, number 6. Kieran thinks he knows one of the linear factors of this polynomial. After finding that p of 3 equals 0, he suspects that x minus 3 is a factor. So he sets up his diagram. So he's going to work backwards. If it's a factor, the whole box should work out. Here's the diagram he made to check his reasoning, but he set it up incorrectly. What did he do wrong? I mean, first of all, you can tell it's wrong because look, these two add up to 7x squared. Is that what that is? These two make a negative or 7x. No. Yeah, the last one's 15, which is fine, but the whole thing has to work. What did he do wrong? X minus 3, he put a plus 3. Should have been a minus here. That would have changed how the whole thing worked out. Okay? Should have been a plus 3, or sorry, minus. Number 7. The polynomial b of x has a known factor at x plus 2. Rewrite as a product of linear. Oops, sorry. Focusing. Focus. All right, 3. 1, 2, 3. Third degree. They gave you one of them. X plus 2. I'm going to work backwards to find the other 2. Backwards is dividing. Last quiz, you multiplied these 3 to give me this. This test, you're going to divide to tell me what the 3 factors were. I'm going to give you one of them. Here we go. X times what? I know this is what goes here. That'll be x squared. So now I can multiply those two. This plus this have to make 8x squared. So that's going to be 6x squared. That's going to be 6x. That's what would make that, which would make this a 12x. These two have to make 5x. Well, I have a 12x. I need to get rid of some. Minus 7x. That'll make my 5. Negative 7. Now, do these two make the last term? Yay! And unlike this problem right here, these two make that, these two make that, and those made that. That's how you know if you did it right. Okay, now I'm supposed to be breaking this into 2 more. How do I do that? I do my Timba puzzle. Timba, what 2 numbers multiply to this last term, but add to the middle? 7 and 1 minus 1. So that means this is x plus 7, x minus 1. This is b of x. It's the same one. It's just written in factored form. All right, guys, I hope that helped. I'll see you soon.